Hello everybody and welcome to our today's webinar dedicated to FRILO Steel Solutions. My name is Wiktoria Rakowska. I'm responsible for partner management and international sales at FRILO Software headquarters in Stuttgart. I'm here together with my colleague Katharina.
Hello and a warm welcome from me as well. My name is Katharina Fischer and I work in product management at FRILO. My job includes customer support as well as technical support for development in steel construction.
Thank you, Katharina. A couple of words to our agenda today. For those that are hearing of FRILO for the first time, we will have some short company introduction. Then we will switch to user interface and show you the look and feel experience from the perspective of a normal user working with FRILO solutions. Then I will hand over to Katharina and she will give you a deep dive into several steel solutions. And in the end, I will explain you the licensing model and how you can download the demo version and test FRILO solutions yourself. So let's start. FRILO is offering innovative solutions for structural engineering and structural design. We are developing our solutions with the help of structural engineers. It means that all of our developers are at the same time engineers, and in this way they understand the needs of our customers in the best way and can deliver solutions offering really intuitive operations for our customers. On the other hand, we have a very qualified service team consisting of our product managers that are on one side in constant touch with the development team. On the other side, via the hotline, they are collecting all of the feature requests and feedback from our customers. FRILO solutions are adapted to the latest norms and standards, and we have Eurocodes implemented in several national annexes in the FRILO solutions. The company exists since over 40 years. It was founded in 1978, and we are indeed having a leading position in the software for structural engineering and design in Germany. The portfolio consists of more than 100 solutions. It's in fact for today around 150 individual programs that can be used independently on other solutions, but they have some interconnections between different solutions there where it is relevant. Nowadays, more than 6,000 companies have acquired FRILO solutions and around 50,000 users are working with FRILO on an everyday basis. Our team consists of 64 colleagues. Most of them are employed in the product management and development department. A couple of words on the solution groups or program groups that we are offering. The first group or category is solid construction. There we have some masonry solutions, some reinforced concrete solutions, as well as slabs and walls by finite elements. Another category is timber and roof solutions. Then we have a big list of steel solutions, foundation and soil analysis, framework solution for the calculation of frameworks in 3 materials, in reinforced concrete, steel and timber. A building model, the so-called GEO, it is a solution that allows you to transfer the entire models out of architectural programs or out of other 3D programs, and then distribute the characteristic loads in the entire building, and such individual building components equipped with this individually assigned loads can be handed over to further FRILO solutions for structural analysis and design of the subsequent building or construction elements. And last but not least, the document designer is the solution allowing you to integrate results the calculation results coming out of different FRILO items that you have calculated into one overall output document. Okay, now we will switch to the live demo and I will demonstrate you how our structural engineers are working with FRILO on their everyday basis. After starting your FRILO solution, you are routed to this first screen where you have the long list of FRILO programs. you can limit the display of these programs to a certain category. For example, FRILO favorites, where you can save the programs that you use more often and then have them in a quick access screen here. Then we have a reinforced concrete category, framework, steel construction programs, timber and roof solutions, slabs and walls by finite elements, soil mechanics and foundation programs, masonry, load programs, and toolboxes, which are small programs that are replaced in manual calculations or calculations with Excel sheets that are solving some structural engineering everyday tasks of our customers. Except for this area, we also have a project management environment where you can store your structural analysis projects. On the left side, you have a structure, this tree structure of different levels that you can set up as many folders as you want and as many folder levels as you want. And in these folders, you can store your structural design projects. The projects are displayed on the right side of the screen. And the programs or items, calculated items that belong to each project are displayed in the bottom of the screen. For example, if I look at the project demo document designer, I can see that it includes some wind and snow loads item, so the calculated wind and snow loads with regard to this project, then trusses, timber, truss joint, timber wall, timber column, stairs, and so on. This icon on the left side means that the results of this item are included into the document designer. So the output document that we will issue with regard to this project will include the results related to this item. We can decide whether we would like to include all of the items that we have calculated in the project into the document, or we would like to exclude some of them. To enter the document design, you have to double click on it, on the project, exactly, and then you are routed to this structure where on the right side you have this document displayed. On the left side you have the table of contents and all of the items that you have selected for your output document that are structured into chapters. Of course, you can create different chapters, you can assign different items to individual chapters, and you can decide if you would like to display all of the sections related to each item in your overall document. For example, if we look at this single span steel beam, we can see that we have basic parameters section, system, graphics, and so on. If you would like to switch off the graphics 2D, it's enough just to uncheck this checkbox on the right side. And the entire document will be adjusted and the page numbers will be adjusted so that you have only those elements that you need in your output document. You can create your own design, your own header and footer. You can add your title page. You can here also add some new items or existing items out of the list of the calculated items in this particular project. So if we have something that we have not added yet, but it is calculated, we can select it here and it will be included on the level where we are with our mouse, standing with our mouse. We can also add some existing files in different file formats, and we can even create new files here out of the document and save them on the certain level of the document. It supports versioning, the table of contents is created automatically, and last but not least, you can insert so-called note or remark on every level of the document structure. Then you have to just right-click on this level, then insert note, new remark, and then you can type anything. You can even insert some tables or paste images, and after you save and exit, exactly on that level where you were with your mouse, this note or remark will be inserted. And that's a very useful function because, in fact, you don't have to care about the pages, where on the page everything will be again adjusted. You see, this is the text that I have written right now, and the table of contents will be adjusted. So it's a really very useful tool for your project management and for generation of the output results. Now I will show you how you can work with some example program. So we will switch to the program area again, and because our today's session is dedicated to steel construction, I will show you a a single span steel column. So let's double click on the program in the list. And first, we have this wizard displayed. In the wizard, we can already preset our column system. We can select the type of support from the drop-down list, adjust the height. For example, let's make it 6 meters. I think I have a caps lock. Yeah, exactly 6 meters. And then you can select the cross section out of the cross section table. Then you can apply some loads, vertical, variable loads, so adjust a little bit, and some other parameters in your system. You can save these settings as a template and then use it later if you need it. And if you click on OK, you are starting the program. In the biggest part of the screen, we have the interactive graphics, and this graphics allows you to adjust some loads or the geometry of your system already in the graphics. Under the right click, you have some context menu available where you can adjust other parameters with regard to your system. On the left side, you have this tree structure, which also allows you to set up your system to enter all of the parameters and then calculate the column. So you can decide whether you prefer to work with interactive graphics or you'd like to work with this menu on the left side. To calculate the column, you have to click on Calculate, and then you will have the results displayed in the right bottom corner. You can see that the system is stable and the cross-sectional bearing capacity is okay, serviceability is okay, so the column will hold these loads that are applied to it. You can have a look at the detailed results under this ribbon results, where you can click over certain different values with regard to your results. And the document with regard to this concrete item is displayed under the tab Document. So this includes the calculation results and the description of the system parameters. And in the end, you can decide if you'd like to have the brief output or if you would like to have an extended standard output that has a little bit more information than a brief output. Okay, so I think now I am through with my online demo. So let's get back to our presentation and hand over to my colleague Katharina Fischer, who will give you the deep dive into the steel solutions of FRILO. You're welcome, Katharina.
Yes, thank you, Wiktoria. I will share my screen. So today I would like to introduce you to our FRILO software steel construction solutions. And in this context, I would like to show you the workflow between the programs Portal Frame S7 Plus and Frame Corner Steel SRE Plus. But first of all, I would like to give you a brief overview of our FRILO software steel construction solutions. FRILO's philosophy is component-oriented structural analysis, and that is why FRILO offers numerous individual solutions. For steel construction, we offer various programs for the verification of steel structures such as beams, columns, frames, and crane runways. And these programs are supplemented by various modules for special detailed verification. To design steel structures, we have the following programs in our portfolio, which you can see on the left side of the slide. The program Single Span Steel Beam STT Plus performs structural safety analysis in accordance with the equivalent member method for single span beams. The program continuous beam STM Plus is used to calculate single span and multi-span steel beams, and a cantilever beam is selectable as a special case. The program steel column STS Plus is used to perform structural safety verifications in accordance with the equivalent member method for centrically and eccentrically loaded columns. Then we have the program steel frame STR Plus. It is used for simple and quick calculation of plain steel frames. The program portal frame S7 Plus is used to calculate plain single bay portal frames. And I will go into more detail about this program later. Then we have the program Lateral Torsion Buckling Analysis BTII Plus. It carries out all the necessary structural safety analysis on straight steel bar systems with any type of supports. The stability check can be performed according to the second order bending torsion theory or according to the equivalent member method. The program stability analysis for steel STX Plus is used to perform stability verifications for single part members based on the equivalent member method. And then we have the program Truss Steel FWS Plus. It is used for the calculation of steel trusses and trusses typical for the construction of portal frames. The program steel bracing ST12 Plus is used for the calculation of steel bracing, as is typical in the construction of portal frames. Then we have some special solutions for the calculation of crown ray girders, buckling analysis, and for the design of steel chimneys and antenna masts. In the section of detailed solutions for steel construction, we have the following programs, which you can see on the right side of the slide. With the program Frame Corner Steel SRE Plus, bending resistant frame nodes of steel structures can be designed. And I will go into more detail about this program later. The program Butt Plate Joint SPS Plus is used for the design of moment bearing bolted butt plate joints in steel construction. And with the program Fin Blade SFB Plus, fin blade connections in steel construction can be designed. The program Steel Column Base ST3 is used for the design of unbraced foot slabs, and the foot slab is supported on a motor joint on concrete. The program Steel Girder Support ST4 is used to calculate various beam supports, and the program Weld Design ST5 is used for the design of filled welds for any standard road profiles. Then we have the program Pocketed Steel Column Base ST6, and it is used for the verification of the base points of steel columns braced in pocket foundations. The program Steel Section Design ST7 performs the structural safety verification of steel cross sections, and the program Typed Steel Connections STY Plus is a program on that I will go into more detail on the next slides. The program Bolted Steel Connections ST9 designs bolted connections in steel construction, and the program Shear Panel Stiffness ST13 is used to calculate the shear and torsional spring stiffness, as well as the translation bedding in trapezoidal sheets. The program Base Flange ST15 calculates pipe flange joints and base points of circular components, as well as single flange connections. And last but not least, the program Thin-Walled Cross-Section Q3 is used for modeling and calculating cross-section values of thin-walled profiles of steel construction that can be combined in any way. Okay, now I want to introduce you our new version of the program Typed Steel Connections STY Plus, which we launched in the last release, and it is the follow-up to the program ST8. First, I want to tell you some general facts about the typed steel connections according to the DSTV guidelines. The ring binder of the German Steel Construction Association, shown here on the left, contains load capacity tables for so-called typified connections in steel construction. Typed connections are clearly defined connection configurations with firmly defined geometry and material data. The ring binder is only valid for steel grades S235 and S355. The type connections are divided into moment bearing and pin-jointed I-beam connections, and the load bearing capacities of the connections given in the ring binder were calculated according to DIN EN 1993-18. The load bearing capacity tables are typed approved and can be used without further examination by the building supervisory board. And the requirements for permissible use are listed in detail in the ring binder and must be observed by the user. Okay, now I would like to introduce you to the innovations in the program STY+. The program can be used to dimension bending resistant and pin jointed connections based on the previously mentioned ring binder. And we implemented an interactive graphic, and so changes can now be made in the graphic. For example, when you click on the screw, it is possible to adjust the preference for the screw strength and the screw size. Or when you click on the beam, you can adjust the system, the profiles, the material, or the position of the beam. Furthermore, we improved the graphics in general, and we also implemented a new connection variant for beam with notch on sheet metal. This can be used to illustrate a connection of a beam to a column web if the flanges of the column are not far enough apart for the beam to fit between them. In addition, several load case combinations can now be defined. And last but not least, we have completely revised the output. If you are interested in the program, you can use it as a trial for 30 days. Okay, as I already mentioned, I would like to show you the workflow between the programs Portal Frame S7 Plus and Frame Corner Steel SRE Plus. First, I would like to say a few introductory words about the programs Portal Frame S7 Plus and Frame Corner Steel SRE Plus. And after that, I would like to show you the workflow between the programs. The program Portal Frame S7 Plus was developed for the simple and efficient design of single-space steel hall frames. The quick and easy input of geometry and loads reduces the workload. Ridged roofs, single pitch roofs, and flat roofs are available as roof shapes. And furthermore, roof overhangs and asymmetrical frames can be modeled. And last but not least, different steel grades can be selected for the beam and the columns. The program Portal Frame S7 Plus also offers interfaces for transferring connection details to other steel design programs like Frame Corner Steel SRE Plus, Butt Plate Joint SPS Plus, Steel Column Base ST3, and Isolated Foundation FD Plus, as shown in the picture on the right. Now a few brief facts about the program Frame Corner Steel SRE Plus. Depending on the licensed option, bolted or welded bending resistant frame nodes of steel structures can be designed in the program SRE Plus. The software performs the required verification regarding structural safety and the welded connections, and the design is based on the components method. The input is limited to double T profiles, and critical components are marked in color in the 2D graphic if the utilization is greater than 1.0, as you can see in the picture on the right. In today's demo, we would like to show you the workflow between the programs Portal Frame S7 Plus and Frame Corner Steel SRE Plus. Let's start. After starting the program Portal Frame S7 Plus, an input assistant opens and the basic system parameters can be entered. In today's example, we want to enter a single pitch roof, and the dimensions are to be entered via the system dimensions. The span length of the frame is 9 meters. And for the eaves height, we choose 3.8 meters on the left and 3.1 meters on the right. And the frames are spaced at 3-meter intervals, and an inner frame is to be dimensioned, leaving the selection unchanged. Then we define the thickness of the roof construction as 0.05 meter and the wall thickness as 0.1 meter. For the column on the left, we choose a HEB 140. And for the beam, we choose an IPE 240. And for the column on the right, we choose also a HEB 140. The building is to be 9.4 meters long, and the pre-selected municipality for automatic determination of wind and snow loads is adopted. Further details, such as the steel crates, horizontal supports, or haunches, can now be entered in the program itself. In our example, we want to define haunches at the frame corners. To do this, we can enter them under the menu item System and then Cross Sections. The haunch should be 0.5 meter long on the left and 0.24 meter high. In addition, the haunch is to be designed with a corner blade and a flange. The haunch should be also 0.5 meter long and 0.24 meter high on the right, and it should also be designed with a corner blade and a flange. Furthermore, we want to assign a different steel crate to the beam than to the columns. To do that, we click on the beam and click on the menu point Material. Then we select the option Beam and Column Different and choose the steel crate as 355 for the beam. Then we close the input. The load is generated automatically from the dead weight and the roof construction. In addition, the wind and snow loads are also created automatically. These can be shown graphically by selecting the load case in the menu. For example, the wind load from the left side, case 1, or the wind load from the left side, case 2. We change back to the permanent load case. If further loads are to be entered, this is done via additional load cases, as you can see in the table below. But in today's example, I don't want to define an additional load. In our example, we want to reduce the standard roof load to 0.5 kilonewton per square meter. Okay, now we want to calculate the system. For this, we click on the button Calculate. The program automatically creates all possible load combinations according to the safety concept of DIN EN 1990. And the design is carried out according to the currently valid standards in Germany and Austria. The Eurocode is implemented, but other national annexes are not yet available, but the coefficients can be adjusted manually. Furthermore, the program performs all relevant verifications. As you can see in the right corner below, in our example, the stability verification is not fulfilled at the beam. Because the beam is to be held by a bracing, we can additionally enter horizontal supports in the third point. And the first support is already existing at 0 meter. The second support is placed at 3 meter and the next support is placed at 6 meter. The point of application of the horizontal support should be in the component axis. And for the last support, we have to add an additional row. This should be placed at 9 meter and also in the component axis. Okay, now we let the system calculate again. And this takes a short while and we will wait for it. Okay, now all verifications have been fulfilled and we want to transfer the left frame corner to the program Frame Corner Steel SRE Plus for design. To do this, we will have a look at the moment curve and we memorize the corner moment on the left side of the frame. It is 31.5 kilonewton meter. To transfer the frame corner, we click on Connections under the menu item Design, and the transfer options are shown here. For example, we want to transfer the left frame corner as a screwed version. This is already pre-selected and I select the corresponding option by clicking on it. The program Frame Corner Steel SRE Plus then opens. This takes a short while and the internal forces are automatically transferred from the program S7 Plus to the program SRE Plus. After opening the program, we first let the system calculate directly by clicking on the button Calculate. After calculating, we see that the dimensioning was successful and the utilization is 43%, as you can see in the bottom right corner. You can also have a look at the frame connection in 3D when you click on the icon in the upper right corner. And after that, it is possible to rotate the connection around its own axis to be able to view it from all sides. Okay, next we adjust the connection suggested by the program. The first thing we do is to adapt the front plate. We can do this the easiest way in the interactive graphic. To do this, we can simply click on the plate and an extra input window will open. The height of the plate should be 500 millimeters and the width 140 millimeters, and the plate should be 15 millimeters thick. For the welding seams on the flange, we enter 5 millimeters, and for the weld seam on the web 4 millimeters, and then 5 millimeters again. We confirm the input with close. The next step is to adjust the screw pattern. First, we click on the dimension chain to open the menu for adjusting the screw pattern. And after opening the menu, we want to place 4 rows of screws lengthwise, and we make the corresponding selection. Now I enter the distances between the screws. 80 millimeter for the screw spacing in the cross direction, and now the spacing lengthwise. 60 millimeter, 100 millimeter, 140 millimeter, and 100 millimeter again. And after that, we confirm the input again with OK. Then we want to change the screw size from M16 to M20. To do this, we click on the screw in the graphic, and in the dialog box, we select the screw size M20. Furthermore, I want to add a rib in the support. You can also add the rib graphically, quick and easy. The rib should be 10 millimeter thick, and we confirm the input with close. Then we click on Calculate again, and the dimensioning was successful. The results are summarized in a well-structured document and can be conveniently added to your structural analysis. You have the choice between a short output and a detailed output with more details. We select the standard output as an example and take a short look at the document. The document is created in tabular form. This will take a short moment. Okay, at the beginning you will find a 2D overview of the connection. Furthermore, you will find general information about the connection, such as the cross-sections, the bolts, or the material. In addition, the load combinations that are relevant for the design are summarized in a table. And at the end of the document, you will find a well-structured summary of all maximum results, as you can see here. Okay, now we close the program SRE Plus and go back to the program S7 Plus. Back in the program S7 Plus, the rotational stiffness of the frame corner can be adopted automatically. For this purpose, only the check mark must be set. And the rotational stiffness is then recorded by a torsion spring in the static system of the frame, as you can see in the table here. Okay, now we let the system calculate again. The rotational stiffness leads to an increase in the deformation of the structure and to a change in the internal force distribution, which in turn causes a reduction in the corner moment and an increase in the field moment. In addition, modified materials or cross-sections can also be transferred back from the program SRE Plus to the program S7 Plus. And the focus of the entire workflow is on an economic dimensioning of moment load-bearing connections under realistic consideration of the real load-bearing behavior. The interface between the programs allows iterative calculations and enables the overall optimization of the frame construction. It is also possible to transfer the loads of the supports to the program steel column base ST3 and isolated foundation FD+, as I already mentioned. And finally, I would like to show you exemplarily the transfer to the program FD+, which is used for the design of foundations. We also click on Connections under the menu item Designs and select the corresponding option by clicking on it. When transferring, you can choose whether you want to transfer the internal forces according to first order or second order theory. And I choose the first order theory as an example. Then the program FD Plus opens automatically and the loads are transferred load case by load case. After starting the program, the geometry can be easily modified in the graphic. And for example, the foundation should be 1 meter long and 1 meter wide. For our example, the verifications are fulfilled and the foundation is sustainable. As you can see, the design of the foundation can be done fast and simple. Okay, that's it from my side. And I give the floor back to my colleague Wiktoria. Thank you for your participation.
Thank you very much, Katharina, for this very interesting workflow between different FRILO solutions, SRE Plus, S7 Plus, and in the end, FD Plus. I hope you enjoyed it. And now we are getting back to our presentation, and the last part is dedicated to FRILO licensing model. I will just quickly check if you can see my screen. Yes, you can see my screen. And in the end, I will show you how you can download the trial version and test FRILO solutions on your own. FRILO licensing model is extremely flexible. We are offering the so-called floating web license, and this license requires only an internet connection. And you can install the FRILO application and upload the same license on several computers, on several working stations, for example, in your office and in your home office. And all you need to do is to close your FRILO environment on one device to be able to start working on the other device. So this is possible with one license. If you need further working places, then you can either acquire a further license of one of the programs that you have in your already purchased portfolio, or acquire the next so-called seed. That's also not a big amount, and you can then enjoy working with FRILO on several computers in parallel. You can either subscribe FRILO and then pay the so-called subscription fee monthly or annually. And on the other side, we still keep our perpetual licensing model, where you can buy a license either with a software service agreement or without it. Then you are able to buy updates each time we have a new release in the market. Okay, the last part of our today's presentation is the installation guide. That's really very simple. On our webpage, you will find this button, which is called Free Trial. If you click on it, you will get a short form displayed that you have to fill out. And after you click Submit, you will get the confirmation email with a link to the download of the license. After you have downloaded this trial license, you have 30 days, but not from the download of the license, but from the start of each program individually. It means that if you have downloaded the license and started to test the reinforced concrete column, for example, all of the other programs in the long FRILO list, they stay untouched, and your trial period was not initiated yet. So you have really this convenience to test one program after another, depending on which solution you are interested in. Okay, that's it from our side. And now maybe let's have a look at our questions area if we have some questions. Okay. I can see we have one question. Katharina, I think it's related to steel solution, so maybe you can take it over.
Yes, the question is if the continuous beam program STM Plus calculates systems under torsion. When you want to calculate systems with planned torsion, you have to use the program BTI Plus. So the program STM Plus isn't able to calculate systems with planned torsion.
Okay. So from my side, thank you very much for your participation in today's webinar. Thank you for your attention, and I hope you have heard certain informations that were new for you from the perspective of FRILO and in particular steel solutions. So thank you very much and enjoy the rest of your day.
Yes, thank you for your participation, and we wish you a nice day.